In this video, I just want to demonstrate how you can use GeoGebra to explore the behavior of the complex roots of a quadratic. So to get started, I'm going to just sort of explore this question here, which is how are the roots of ax squared plus bx plus c affected by varying a, b, or c? And I mean the complex roots in this case. And so I'm going to move down into my input bar. I'm going to type a space x squared plus b space x plus c. You may or may not need the spaces, but just to be safe, put them in. I hit enter. It should ask me if I want to create sliders. I'm going to say okay, and I'm going to turn that question off so it's out of my way. And for some reason, these sliders didn't default to turn on, so I'm going to just click over here in the algebra view, turn those on. And now I should have a quadratic graph here, and I should be able to vary a, b, and c and observe the behavior of the functions. So how does b affect the graph, how does c affect the graph, etc. And then if I set this, I want to find the roots of this quadratic, and I want both real and imaginary. So in the input bar, I'm going to type complex, and complex root pops up. I'm going to click on that, and my polynomial is f. So I'm going to say complex root f, and when I do that, it plots z1 and z2, and that's about all you need. Now the question is, what's going to happen to these two roots as I start varying c? And it gets more interesting as the vertex gets above, in this case, and so you can see the behavior of the complex roots. And in this case, it's probably also worth mentioning that GeoGebra treats this as the x-axis, this is the y-axis, while at the same time treating this as the real axis and the imaginary axis. So the question that I would pose to you is, what will happen if we start to vary a on its own or b on its own when we have these complex roots? Have fun exploring.